What's the future of the solutions architects in the age of agentic AI, and how to stay ahead? Over the past decade, the role of the solutions architect has been one of the most strategically important positions in technology organizations. Solutions architects design systems, align technology with business goals, select platforms, manage trade offs, and ensure scalability and security. But now we are entering a new era. Generative AI can write production ready code. AI coding assistants can refactor systems, generate APIs, write tests, and even migrate legacy applications. Agentic AI systems can plan multi-step workflows, call tools, retrieve documentation, and execute tasks autonomously. So the question becomes unavoidable. If AI can design components and write most of the code, what does the future solutions architect actually do? And how should software engineers and architects prepare for this shift? This video is for solutions architects, senior engineers, cloud professionals, CTOs, and technology leaders who want a realistic, forward-looking view of how their roles are evolving in an AI-driven world. Let us begin with a clear premise. Generative AI and agentic systems are transforming how systems are built. They are not eliminating the need for architecture. They are increasing the importance of architecture. The difference is that architecture is moving up the abstraction stack. Today, AI tools can generate microservices, infrastructure as code templates, database schemas, and API integrations. But those outputs are only as good as the constraints, context, and requirements provided. Someone still needs to define the problem, evaluate trade-offs, understand compliance requirements, assess security risks, design integration patterns, and ensure long-term maintainability. That someone is evolving into the next generation solutions architect. Let us take a closer look at what is changing. Traditionally, a solutions architect would design cloud infrastructure, choose between relational and NoSQL databases, define service boundaries, create integration patterns, and review code for alignment with architectural standards. In the AI era, much of the tactical implementation is automated. Infrastructure can be provisioned with AI-generated templates. APIs can be scaffolded instantly, test coverage can be auto-generated. The architect's value shifts from drawing diagrams of systems to designing decision frameworks for intelligent systems. Now let us examine how agentic AI changes system design. Agentic systems are not just predictive models. They can plan, reason across steps, call external tools, retrieve data, and execute actions. For example, an AI agent inside an enterprise system might retrieve customer records, generate a financial summary, draft a proposal, and send it for approval. Designing such systems requires understanding model limitations, latency trade-offs, orchestration layers, data governance, observability, and human oversight mechanisms. The future solutions architect must understand not only distributed systems, but also AI system lifecycles. This includes how models are selected, how prompts are structured, how retrieval augmented generation works, how embeddings and vector databases are used, and how outputs are validated. Let us make this concrete with an example. Imagine a healthcare provider implementing an AI assistant for clinicians. The assistant summarizes patient records, suggests clinical guidelines, and drafts documentation. A traditional software engineer might focus on API integration and front-end development. A future-ready solutions architect must design the entire trust boundary. Where does patient data reside? How is it encrypted? Is the model hosted internally or via a managed service? How are hallucinations mitigated? What is the human-in-the-loop process? How are outputs logged for audit? How does this align with healthcare regulations? These questions are architectural, not coding problems. Now consider life sciences. A pharmaceutical company deploys AI to accelerate drug discovery. The system integrates laboratory data, public research databases, molecular simulation engines, and generative chemistry models. The architect must orchestrate data pipelines, ensure reproducibility, manage versioning of models, integrate high-performance computing resources, and maintain traceability for regulatory review. Again, the complexity shifts from writing code to orchestrating ecosystems. In the technology industry, SaaS companies are embedding AI copilots into their products. An AI assistant inside a project management platform might generate task summaries, forecast delays, and automate workflows. Here, the architect must decide whether to use a foundation model API, RAG, or a fine-tuned internal model. They must evaluate cost per token, latency requirements, fallback strategies, monitoring tools, and abuse prevention controls. Now, let us address a common fear. If AI can generate most of the code, will software engineers become obsolete? The evidence so far suggests a different outcome. AI coding assistants increase developer productivity, but they do not eliminate the need for developers. Instead, they change the skill distribution. Engineers who focus purely on writing routine code are more exposed. Engineers who understand system design, security, orchestration, and domain context become more valuable. The same applies to solutions architects. The future architect is not primarily a diagram creator. They are a system strategist, AI orchestrator, risk manager, and integration leader. Let us break down the core capabilities that will define the future of this role. First, AI systems literacy. Architects must understand how large language models function at a practical level. Not the mathematical details of transformer architectures, but the operational implications. Context windows, token limits, prompt injection risks, hallucination patterns, and retrieval mechanisms. Second, orchestration and workflow design. Agentic systems require orchestration layers. This may involve event-driven architectures, API gateways, vector databases, tool calling frameworks, and human approval steps. Designing these flows requires deep understanding of distributed systems and failure modes. Third, governance and compliance. In regulated industries like healthcare and finance, AI outputs can create liability. Architects must design systems with logging, audit trails, access control, model evaluation pipelines, and rollback mechanisms. Fourth, data strategy. AI systems are only as strong as their data. Future architects must understand data quality, lineage, privacy constraints, and data residency requirements. In global enterprises, this is non-trivial. Fifth, cost engineering. Large models can be expensive at scale. Token usage, inference costs, GPU utilization, and caching strategies matter. Architects must balance performance and cost. Now, you might be wondering how to prepare for this shift. For solutions architects, the path forward includes expanding beyond traditional cloud certifications and infrastructure expertise. Learn how retrieval augmented generation works in practice. Experiment with vector databases and multi-model workflows. Understand prompt design, agentic architecture, and model evaluation. Study AI security risks such as prompt injection and data leakage. Familiarize yourself with model monitoring tools. For software engineers, the advice is similar but with additional focus on abstraction. Stop competing with AI on typing speed. Start focusing on problem decomposition, system boundaries, and reliability engineering. Build projects where you integrate AI services into real workflows. Practice designing systems with human oversight loops. Learn about observability in AI pipelines. In healthcare technology, engineers should understand interoperability standards and privacy frameworks. In life sciences, understanding reproducible research pipelines and data integrity becomes critical. Another important shift is communication. As AI systems become more autonomous, the decisions about when to trust them become executive level concerns. Architects must be able to explain trade-offs clearly to non-technical stakeholders. The ability to translate between business objectives, regulatory constraints, and AI capabilities becomes a defining skill. Now let us look 2 years ahead. The future solutions architect may oversee fleets of specialized AI agents. Instead of designing every microservice manually, they define policies, constraints, and high-level architectures. AI systems generate implementation artifacts under those constraints. Architecture becomes policy-driven. For example, an architect might specify that all services must comply with zero trust security principles, that sensitive data cannot leave a geographic boundary, and that AI-generated outputs must pass validation checks before execution. AI agents then build and modify components within those guardrails. This resembles how infrastructure as code abstracted manual server management. AI abstracts implementation details further, but abstraction increases the consequences of mistakes. A poorly designed architecture, amplified by AI, can propagate errors quickly. That is why human oversight at the architectural level becomes even more important. There is also a strategic dimension. Organizations adopting agentic AI will need leaders who can redesign workflows entirely, not just automate existing ones. Architects who understand business process transformation will have outsized impact. For example, in a hospital, instead of simply adding an AI documentation assistant, an architect might redesign the entire patient intake and follow-up process around AI-enabled triage and monitoring systems. In a biotech firm, instead of adding AI to one research stage, they might integrate AI across hypothesis generation, simulation, documentation, and regulatory submission preparation. This level of redesign requires systems thinking. To summarize, the future of the solutions architect is not diminished by generative AI. It is elevated. Coding becomes increasingly automated. Architecture becomes increasingly strategic. The role shifts from building components to designing ecosystems. The professionals who thrive will understand AI capabilities and limitations, master orchestration and governance, focus on data integrity and security, and communicate clearly with business leaders. Software engineers and architects who treat AI as a collaborator rather than a competitor will gain leverage. The question is not whether AI will write code, it already does. The real question is who will design the systems that control how AI writes, decides, and acts. That is the future of the solutions architect. Thanks for watching.